All right, next we'll talk about the production possibilities curve, which is the first model that we're introduced to in this course. And we're going to use this model to illustrate this concept of comparative advantage. And then finally, we're going to, in this chapter, use this model to generate a hypothesis, which we'll see how economists would test it. And so see how economists test hypotheses. So first of all, we'll talk simply about constructing a production possibilities curve. So here you have one. You have goods on the x-axis and the y-axis. So the x-axis, which is this one, shows you how many snowboards per month this factory can produce if it uses all its resources to produce snowboards. And so we see that is how many? 100. Right? So by using all its resources, it means all its machines, all its workers, all its raw materials are used to go into making snowboards. On the other hand, if it uses all its resources to produce skis, it can make 200 pairs of skis. This information is given to you here in this table, and then we're plotting this information on this graph here. So in this class, we're going to be doing a lot of graphing. So you should be comfortable with the concept of x and y axis, for example, and graphing. We'll talk more about that as we go on. We also see that if we want to produce some mix, for example, 100 skis, then we can produce 50 snowboards. And we get these 3 points. They all lie on a line, and so we can connect them. And this is the production possibilities curve. Right? Now we're going to use this to illustrate various concepts. First is opportunity cost. Now, maybe I'll back up 1 second. Remind yourself about slope. How do we determine the slope of the line? Rise over run. Right. So what's the slope of this line? If we go from A to B, what is the rise? It's negative 100, right? Because we're not going up, we're going down. So the rise is negative 100, and then what's the run? 50. So it's negative 100 over 50, which is negative 2, right? We can also zoom in on this line. And so let's say we're here at point B, and we want to go from producing, at point B, we're producing 100 skis and 50 snowboards. But let's say we want to produce 51 snowboards. So we go from B to this point B prime. Rise is negative 2. Run is 1. So negative 2 is the slope of this line. Because it's a straight line, the slope is the same here and here and here, right? The slope is the same everywhere. That's a property of it being a straight line. Now, that's the slope of this line. It also is the opportunity cost of producing a snowboard. Why? Because when we go from producing 50 to 51 snowboards, we get another snowboard, right? But we give up skis. And how many skis do we give up? 2. So the opportunity cost of producing snowboards is skis, and we can say exactly how many 2 pairs of skis. If you want to know the opportunity cost of producing a snowboard, the opportunity cost of producing a ski, then you have to go backwards and say, okay, so here we are at 98 skis. And then we want to produce 1 more ski. So we go from 98 to 99. How many snowboards did we give up? Half a snowboard. So the opportunity cost of producing a ski is half a snowboard. I know that this is confusing, but you'll get the hang of it if you think about it for a while and work on the problems that you have. The opportunity cost of something is always in terms of something else, right? So it's not the cost is $50, it's how many skis did you have to give up. So that is, to make concrete, the way that economists think about opportunity costs. Okay, so she may have, this story is about an entrepreneur who has 3 factories, in fact. And we see that all of these factories can produce 100 snowboards if they allocate all of their resources to snowboards. So they're identical with their ability to produce snowboards, but they differ with their ability to produce skis. This factory can produce a lot of skis, 200 if they use all their resources for skis. This one only 100, and finally this one 50. And so you could see that the opportunity cost of producing snowboards is different for each factory, right? Here, to produce 100 snowboards, how many skis do you give up? Or 200, right? So the opportunity cost of producing 100 snowboards is 200 skis. This is sometimes an easy way to think about opportunity costs. So I'm going to go through the trouble of writing it down for you. Okay, you see, you can just calculate the slope of the line. It's one way to determine the opportunity cost. But sometimes it's helpful to write it out. The opportunity cost of boards is 200 skis. Now, let's say we just want to know the opportunity cost of producing one snowboard. The opportunity cost of producing one board is how many skis? 2. Because we need to divide this by 100 to make it 1. Therefore, we need to divide this by the same amount, or 100, and this becomes 2. So that's one way to look at these graphs and quickly determine the opportunity cost. You can also do it the other way and say the opportunity cost of producing 200 skis is 100 snowboards, or the opportunity cost of producing 1 ski is 1/2 of a snowboard. Right? So with the straight line PPC is short for production possibility curve, you can quickly determine opportunity cost, right? Either by looking at the slope of the line, or as I was showing you, calculating the slope by looking at the 2 endpoints. So you should review that part of the video if you were confused on that. In this figure, we imagine that she wants to use her plants together to produce some combinations of ski and snowboards. So assume she's here, using all of her factories to produce skis. One factory produces 200, the other factory produces 100, and finally the other factory produces 50. So they produce 350 skis total. Now she wants to produce 50 snowboards. Which factory should she use to produce those snowboards? Right now, imagine all 3 factories are producing only skis. But she wants, 100 snowboards. So which factory should she use? Plant 3. But why? Is Plant 3 better at producing snowboards than the other plants? It has a lower opportunity cost. That is the key insight for why she should use Plant 3 to produce those snowboards. It's not any better than the other factories. However, you give up less. Right? You only give up 50 skis if you take this factory out of ski production and put it into snowboard production. In other words, the opportunity cost of putting Plant 3 into board production is the lowest. And you see that by the slope is the flattest here. But if she needs even more snowboards, say because her customers are demanding more snowboards, so she needs to produce more snowboards, then she needs to put Plant 2 into board production. But that is costlier in opportunity cost terms, right? You see that by the steeper line. Finally, if she needs to produce 300 snowboards, she'll put her first plant into snowboard production. But then she's giving up a lot of skis, right? 200 skis. So that's a high opportunity cost. There are 2 things the main thing to note here is that this has now a bowed out shape. That illustrates increasing opportunity cost. As you dedicate more resources to producing something, the cost of doing it increases. And this is true for her her ski and snowboard operation, but also for economies as a whole. So imagine that our economy, we can produce cars and computers, imagine. And right now we're using our resources to produce half of them to produce cars and half of them to produce computers. But all of a sudden we start producing more cars. Where are we going to get the resources to produce more cars? From computer production, right? So we're going to have to take resources away from computer production, put them into car production. Now some of those resources are well suited for car production. Some of the workers, for example, are just as good at making computers as they are at making cars. But what about when we take the last worker out of computer production? He's probably, or she probably, is not a very, muscular person. They're probably good at typing and computer programming and so on. Nothing against computer programmers. You can, I know that you come in all shapes and sizes. But point being, some resources are better suited towards computer production. And so if you take them and put them into car production, first of all, you're not going to gain many more cars, right? But you're going to lose a lot of computers. That's the law of increasing opportunity cost. As you do more and more of something, eventually it's going to become more and more costly to do it. Okay, we've illustrated opportunity cost with the PPC. But now let's distinguish between movements along the PPC and also shifts. We've already spoken about movements along it, in fact. Here is a PPC for an economy that can produce two things: security, and think about like the TSA at the airports, and then everything else. And so we are at point A, and then 9/11 happens. So we want more security. Well, we can't get more security without giving something else up, right? So we move from A to B along the curve, and we get less of everything else. So there's a trade-off that we have to make. Whether we want more security, we have to decide whether we're willing to give up more things. So that's the opportunity cost of security. But we can also use the PPC to illustrate this concept of idle factors of production. Because we might have some resources, some workers, for example, who are just sitting at home. In that case, it would be as if the economy is producing at point B. Right? So now imagine an economy that produces clothing and food. Only two things. Again, economists make a lot of assumptions in their models. Here we're assuming the economy is very simple and only produces two things. If we're at point B, this means we have idle factors of production. Workers are sitting at home not doing anything. If we can get them to work, then we can get more of both. Right? We can go to point A. And we have no trade-off here, right? Because we've just utilized our formerly idle factors. But if we're on the PPC, and now let's say we want to get more clothing, we can only get more clothing by giving up food. For example, if we move here, we'll get more clothing, but we'll have given up food. Right? And vice versa. There's also a distinction made here between idle factors of production, that means factors not being utilized, and inefficient production, which means factors being utilized but not efficiently. In other words, not using factors according to comparative advantage. I don't think we've defined comparative advantage yet. So let me say not according to who has lowest opportunity cost, because it pretty much means the same thing. So for example, going back to our snowboard example, if initially we're producing only skis, and then now we want to produce 100 snowboards, we put plant 1 into snowboard production, that would be a bad decision, right? Because we get 100 snowboards, but we give up 200. We give up 200 skis. Right? 350 minus 150 is 200. So that was a bad decision. We should have not had plant 1 make the snowboards. We should have had plant 3 make snowboards. But we made a bad decision. So in that case, we would be here, whereas we could be here, right? We're inside our PPC. That is not because we're not utilizing all our resources, but because we're utilizing them inefficiently. This case in point article about the Great Depression describes a situation where the economy was at a point inside the PPC. The reason for the Great Depression is, the reasons for the Great Depression are topics that you'll discuss in a macroeconomics class. So this is a microeconomics class. It's a good case in point. You should read it. But I would encourage you, when you're thinking about writing your own case in point articles, to think about more microeconomic concepts. Okay, in the next video, we'll move on to Chapter 2, Section 3.